In this video, we're going to be finding the derivatives using the chain rule. Now, you're going to be saying, what do you mean by the chain rule? We're going to be looking at composite functions. We're going to be looking at functions that are found inside other functions. So we're going to be looking at these type of functions, f of g of x, but some books will use this notation, okay, f of g of x. All right, so let's go ahead and look at the objective. Find the derivative using the chain rule. Now, in order to do the chain rule, you have to find a function inside of another function. So in this case, I have f of x. So this is my function column, and this is my g of x. And what we're going to do is we're going to try to find, we're going to put the g of x inside the f of x. All right, that's going to be my composite function. So we're going to take this 2x plus 3, and we're going to insert it in there, and my composite function is going to be the square root of 2x plus 3. In my second example, my original function is sine of x plus 5, sine of x, and my g function is going to be x squared plus 7x. And if I take my g, if I take this guy and insert him in there, I'm going to end up with sine of x squared plus 7x. In my next scenario, I have 1 over x, and I have, for my g function, I have ln of x. So if I take this and plug it in there, I'm going to end up with 1 over ln of x. So that's a composite function. And finally, on the last one, I have x to the 4th for my f function and cosine of x for my g function. So if I take my g and plug it into my f function, I'm going to get cosine to the 4th of x. So that's going to be my composite function. That's what a composite function is, a function within a function. Okay, so what's the derivative using the chain rule? The derivative, if I have f of g of x, the derivative is going to be f prime of g of x times g prime of x. All right, so basically you're going to take the derivative of the function, forget about the function within the function, and then you're going to multiply it times the derivative of the interior function. Okay, all right, here we go. So find me the derivative of square root of 2x plus 3. Now, I want you to go back, and I told you to memorize the derivative of the square root of x. What's the derivative of the square root of x? Oh, the answer is 1 over 2 square root of x. So I see a square root, so the derivative of that is going to be 1 over 2 square root of 2x plus 3. All right? So that would be my answer if it was just square root of x, like this. This and this are identical, except that now you have a function inside the function. So what's the derivative of the inside here? What's the derivative of 2x plus 3? The derivative of 2x plus 3 is just going to be a big fat 2. And that 2 and that 2 are going to reduce, and my final answer is going to be 1 over the square root of 2x plus 3. And this will help me find the slope of this at any point. Okay, let's try another one. So on this one, I told you to memorize the derivative of sine. The derivative of sine of x is going to be cosine of x. All right? So the derivative of sine of function, okay, is going to be, so my derivative here is going to be cosine of g of x, which is x squared plus 7x. And then you're going to take this and you're going to multiply it times the derivative of your g function, which is 2x plus 7. And that is the derivative of a chain within a chain. All right, let's try another one. Now we have a function, ln of x, inside of ln of x. So if we remember, the derivative of the natural log of x is 1 over x. Okay, so the derivative, this right here, is going to be my quantity, my g of x. So the derivative of ln, if this was x, it would be 1 over x. But I have ln of x, so it's going to be 1 over ln of x times the derivative of the ln of x, which is another 1 over x. And that is going to be written as 1 over x ln of x. And that's the derivative using the chain rule. Okay? All right, let's try another one. Now, whenever you have a trig to a power, I like to tell my students to rewrite it. Okay? I like to rewrite it like this. Cosine of x to the 4th power. And you're going to try to find the derivative of this. So what's the derivative? If I had x to the 4th, what's the derivative of x to the fourth. The derivative of x to the fourth is going to be 4x cubed. So in this case, I'm going to end up with 4 bracket cosine of x cubed times the derivative of cosine, which is negative sine of x. And that one is going to be written as negative 4 sine of x cosine cube of x. And this is my answer. Okay? Alright, so let me see if I can come up with a few more. So let's pretend I have the derivative of e to the x squared plus 3x. So what's the derivative of e to the x? Well, the derivative of e to the x is awesome because it's e to the x. So what's the derivative of e to the something? The derivative of e to the something is e to the something. Now I'm going to multiply it times the derivative of my something, which is 2x plus 3. Alright, let's try another one. Let's try the derivative of x squared plus 3x plus 7 to the 5th power. Okay, so now this here is my something. So let's pretend something to the 5th. So that's going to be 5x squared plus 3x plus 7 to the 4th times the derivative. The derivative of this is going to be 2x plus 3. And that concludes my derivative of the chain rule.